So the problem we have basically is a perception problem in which our robot needs to navigate a maze without bumping into walls or navigating to the target location when the target location coordinates are unknown. Our solution has these different approaches. We are using all these different libraries to solve our problem. We have an odometry-based approach in which we were using the NumPy library, and then we are doing an A-star path search algorithm implemented using NumPy and different libraries.
We use a 2D array to store the location of walls and places that we visited or have not visited yet in the maze, and we convert that into an image to help the user as they navigate through the maze. We're also continuously saving the camera's views tagged with the coordinates that were taken from in order to do our place recognition. We're using OpenCV to do wall detection. We know the camera intrinsics matrix, so we can project points along the ground plane relative to the robot's position and see if those seem to be wall or floor tiles, and then use that to update our representation of the maze. That process is a little bit noisy, so we do some more image processing techniques to try to make that a more robust estimate of the walls.
The robot then stores its heading and XY position, displays that so that we know where we are. It prevents collision by not bumping into walls because we know the occupancy grid where the walls are. It turns 90 degrees left or right because we map the direction keys in that way.
We were also able to come up with a fully automated exploration, so no user input needed, using A-star to repeatedly try to find a path to unvisited locations, but this wasn't fast enough for the final version. The place recognition is done using bag of visual words for each image that we've seen before. We compute the SIFT features, cluster those together to build the visual words and build a histogram of the closest matches. From that, we can get a short list of potential matches, and then we do another round of feature matching to pick the image with the best matches.
We navigate using the target location, which are decoded from the file path. We have an occupancy map in which the start and end goal coordinates are input into the function. We use the neighbor and cost function in which the cost of one is assigned to move from one node to another. We introduce turning costs to influence the selection of paths with the fewer number of turns. We estimate the total cost using Manhattan distance as heuristic, and we store the reach cells and their cost.
So this is what it looks like in practice. You can see as the user guides the robot through the maze with the keyboard, that is automatically keeping track of the walls it's seen and the visited locations.
It's going to speed up now.
And then once it reaches the end of the exploration process, it's going to start computing the SIFT features and doing the clustering to build a bag of visual words, which takes a little bit. And then once we're given the target images, it's able to quickly find the closest matches from the place recognition database and navigate to the location. You can see it traversing the shortest path there. And we can also see the features that were matched between the query images and the ones in our database.